Tonight, you're going to look up at the stars and you're going to feel small. That's normal. That's expected. But here's the strange part. The stars might be looking back at something that came from them, not metaphorically, literally. Some scientists believe the first ingredients of you, the actual atoms that build your cells, may have crossed the void of space before they ever touched Earth. Is that possible? It sounds like science fiction. It isn't. For most of your life, you were taught a simple story. Earth formed. Oceans filled. Lightning struck a pool of chemicals. Life sparked into being, right here, right now, homegrown. It's a tidy story. It fits neatly on one page of a textbook, but it has a hole in it, and the hole is bigger than most people realize. Scientists still cannot fully explain how non-living chemicals became living, self-replicating cells in the short window of time available on early Earth. And that gap has pushed some of the most respected minds in science toward a much stranger idea. What if life didn't start here at all? This is called Panspermia. The word comes from Greek, meaning seeds everywhere. Life, or at least the building blocks of life, may have arrived on Earth from somewhere else in the cosmos. Carried on comets, carried on asteroids, carried on dust, drifting quietly through the dark for millions of years before falling, unnoticed, into a young and mostly empty planet. You might assume this is fringe thinking. It isn't. In 1973, the molecular biologist Francis Crick, the same man who helped uncover the structure of DNA, proposed something even bolder with his colleague Leslie Orgel. They called it directed panspermia. Life might not have simply drifted here by accident. It might have been deliberately sent. Seeded by an earlier civilization, launched across the galaxy in tiny capsules, aimed at any world that looked promising enough to grow something. Crick wasn't a fringe thinker chasing headlines. He was one of the most rigorous scientists of the 20th century, and he thought this idea deserved serious consideration, not dismissal. Why would someone that credible entertain something this strange? Because the alternative has its own enormous problem. Earth formed about 4.5 billion years ago, and it spent its first several hundred million years as a molten, bombarded wasteland, unfit for anything living. Yet the earliest signs of life show up almost as soon as conditions calm down. Geologically speaking, in the blink of an eye. That timing has always bothered scientists. Complex chemistry doesn't usually organize itself into self-replicating life that fast, on its own, from scratch, unless it had a head start somewhere else first. Here's where it gets stranger still. In 1969, a meteorite fell near the town of Murchison in Australia. When scientists studied it, they found something remarkable inside: amino acids, the literal building blocks of proteins, the machinery of every living cell in your body right now. These weren't Earth's own molecules hitching a ride home after some cosmic detour. They were extraterrestrial, formed somewhere out in deep space, chemically distinct from anything made naturally on this planet. The rock had carried the ingredients of life across the solar system before it ever reached the ground. If space rocks can carry the ingredients of life, the next question writes itself. Could they carry life itself? This is where astrobiologists like Chandra Wickramasinghe and the astronomer Fred Hoyle pushed the theory even further. They proposed that microbial life, in the form of hardy bacterial spores, could survive the brutal vacuum of space, embedded deep inside rock or ice, shielded from radiation, frozen in a kind of biological hibernation that could last for millions of years. Some bacteria on Earth today already do something similar. Certain extremophiles can survive intense radiation and near total dehydration for extended periods in laboratory tests. Nobody has proven that bacteria have crossed interstellar distances alive, but nobody has proven it's impossible either. You feel that, don't you? That itch of not quite knowing. The evidence didn't stop with one meteorite. In 2016, scientists working with the European Space Agency's Rosetta mission announced they had detected glycine, a simple amino acid, drifting in the thin cloud of gas surrounding comet 67P. This wasn't a rock that had already crashed into a planet and picked up contamination along the way. This was a comet sampled directly out in space, millions of miles from any world, still carrying the chemistry of life inside it. Researchers also found phosphorus on that same comet, another essential ingredient for building DNA. Two of the core ingredients for life, found together, floating on a frozen ball of ice tumbling silently through the solar system. Now bring this back to you, not to some abstract idea of ancient microbes drifting through the void, to you sitting here, breathing, thinking right now. Every atom of carbon in your body was forged inside a dying star, long before Earth ever existed. That part isn't controversial at all. Astronomers have known for decades that heavier elements are built inside stellar furnaces and scattered across the universe when stars explode. Carl Sagan said it plainly, and he said it often. You are quite literally made of star stuff. What panspermia adds to that story is a much stranger twist. Not just your raw materials came from space, possibly the spark of life itself did too. So what does that make you? If panspermia is even partially true, you are not a native of this planet in the way you've always assumed you were. You are more like a descendant of a signal that arrived from somewhere else entirely. unpacked itself in the right conditions, and slowly, over billions of years, built you. Built your eyes, built your curiosity, built the exact impulse that makes you look up at the sky tonight and wonder where you actually came from in the first place. There's a modern mirror to all of this, and it's closer than you think. Right now, scientists are deliberately doing something eerily similar to what Crick once proposed decades ago. Missions like NASA's OSIRIS-REx and Japan's Hayabusa 2 have traveled to distant asteroids, scooped up samples, and brought them back to Earth for careful study. In effect, humanity is now reaching outward into space to retrieve exactly the kind of material that may have seeded life here in the first place. You are not just a possible product of panspermia. You may be its next chapter. Does that feel like coincidence to you? Even closer to home, in 2008, Japanese researchers ran an experiment testing whether tiny, nearly indestructible creatures called tardigrades could survive being bolted to the outside of the International Space Station, fully exposed to the vacuum of space and unfiltered solar radiation. Most died, but some survived rehydrated back on Earth and went on living normally. It's a small experiment. It's not proof that anything traveled between stars, but it's a real, tested demonstration that life, in the right form, can endure conditions once assumed to be instantly and completely lethal. Some researchers take this even further into speculative territory, suggesting that if life can travel between planets, it could theoretically travel between entire star systems too, drifting slowly across gulfs of time so vast that whole civilizations could rise and fall in the gap between departure and arrival. Nobody can prove this. Scientists are careful to say panspermia remains a hypothesis, not a settled fact. But it's a hypothesis serious enough that it has been studied at Cambridge, tested in orbital experiments aboard the International Space Station, and debated in peer-reviewed journals for over 50 years now. Here's the part that should really sit with you. We spend so much energy searching outward for aliens, telescopes scanning distant stars for a flicker of something unusual, radio dishes listening patiently for a signal buried in static, missions searching for microbial life on Mars. But what if the search was never really about finding something entirely foreign? What if it was quietly about recognizing something we already carry inside us? The chemistry that built your body may have crossed the exact same kind of emptiness that separates us from every star you can see tonight. So when you look up, you're not looking at a stranger's sky. You may be looking at home. And if that's true, then the real answer to where you came from was never as simple as the ground beneath your feet. It was written across a distance so vast it makes the whole idea of originally from Earth feel almost too small to hold you. Tonight, when you look up at the stars again, you won't just be looking for something out there. You'll be looking quietly for yourself.